That we have conformed to what this airplane is supposed to be built to. We have to do that before we can get a physical certificate to fly the airplane or to deliver it to the customer so he can put it into commercial service.
We are in fact experiencing some frustrations because of the level of intensity, if you will, that is being placed on the airplane. A lot of us folks are spending a lot of time here, and upwards to 20 hours a day, 7 days a week. This is much like a roller coaster emotionally. We certainly thrive on the successes, and we certainly get somewhat depressed on those failures, but we maintain an equilibrium. Otherwise, it would just drive you nuts or crazy. So we have, in fact, during the course of a day, some sanity checks to make certain that we are, in fact, on course and everything is doing okay.
Our goal Monday morning was first thing in the morning to have the aircraft on the engine trim pad to do the engine functions. We came in, was a little behind schedule on that, and due to a group effort and a very good group effort from a lot of groups that normally aren't involved in this, we got the airplane there in a pretty reasonable time.
No doubt that's certainly exhilarating to come off the fuel pit and go to engine run. Engine run represents one of the last things that we do prior to flying the airplane.
Okay, we're ready for a start on 3.
Okay, you're all clear for 3.
25 seconds from the time he turns the fuel on. Ready?
We start the engines, go through a series of power settings, and see that the computer and the throttles are tracking and so forth.
We run at certain intervals through the power range of the engine. For test validation, we went up to 107%, which is unheard of in terms of maximum engine rating on the ground. And based on that, we only spent a very short time checking him out. It's a culmination of lots of hours and lots of effort, not only by us, but by thousands of teammates. We'll be emotionally charged beyond your wildest dreams. That's conservative. The TQMS implementation was disruptive in nature to a level. However, before TQMS, we were certainly not organized in any fashion, and we were certainly headed toward destruction. We were destroying our company, and I believe that TQMS allowed us to understand what we were doing incorrectly in terms of managing our day-to-day business.
I think it's pulled together quite well. The last 2 months on that airplane has made a huge step in the right direction.
I would expect that after we fly the airplane, we'll take a couple of days off to get reacquainted with our families and then gear up for the second airplane, which also requires a Herculean effort in order to get the program back on schedule. The next 5 to 10 years will certainly go down as some of the most challenging this corporation has ever faced, and I would expect that those that are involved in this process today will look back at the end of the 10 years, and we're simply going to take a deep breath and go, whew, that was tough, but that was great.
Thank you, Ed Chenille, John Million, and everyone on the MD-11 program. By the 1st of February, we had 126 firm orders for the airplane worth more than $12 billion and options for 76 more. We're already building airplanes for delivery as soon as the MD-11 is FAA certified for airline use. As a result, we're investing heavily in inventory buildup. And it's only after we begin delivering airplanes that we get paid by our airline customers. So you can understand our eagerness to get the MD-11 certified and begin deliveries. This is an RFQI, or Request for Quality Improvement. It's a form teammates use at McDonnell Aircraft Company to point out production quality problems. Unfortunately, solutions to problems were delayed by bureaucratic systems. That is, until a first-time quality committee on the F-15E program came up with the idea of a quality support team. It's a small group of engineers who take responsibility for handling RFQIs. And they deal directly with the people who are building the airplanes to identify and solve the problems. If you have any doubt that a team which is accountable can make a difference, watch as Jim Honeycutt, an F-15E inspector, and Rick Oseski, a manufacturing methods engineer, tell us all about it.
Can you see if that's going to be movable enough, or that screw is going to clear that hub stump? Is that going to move enough?
Management had a need to find out why there were so many repetitive problems, especially quality problems out on the floor. Plus, they wanted to try to get the worker involved firsthand in a better communication process. Basically, the purpose of our first-time quality committee was to evaluate our present system of quality. But it's basically a hands-on committee to deal with hands-on problems. On the floor, we run into everything that you can possibly imagine going wrong as far as assembling an airplane goes. We try to utilize our planning, our engineering, our tooling, our corrective action system, and our workmanship. And all of that led about to the formation of a quality support team, because we felt a need to have people in those disciplines on the floor when people had specific problems right at hand. The quality support team was established in April of 1989 with Rick designated as team leader, and Rick's team has responsibility of the forward fuselage area.
Jack trial fit the seat rail in between those mating parts, and we were only off about 35 to 40 thousandths. That's just eyeballing it where it wouldn't fit. The quality support team is simply a multidiscipline team consisting of liaison engineering, liaison planning, firm planning, design engineering. We have a tooling representative, manufacturing methods. When we receive a quality improvement request from the foreman, generally they'll call us, or a shop person. We'll investigate that immediately. When we assign it to our group, we take responsibility internally for that. So now, to maintain a tracking within the quality improvement system for the company, we'll submit a Xerox copy of that work that F-15 Forward Fuselage Quality Support Team 1 has accepted that, and we'll put our phone number on it. So now we're accountable to the system, and we're responsible for making sure that engineering receives it if they need to, that tooling will work on it, that planning works on it. So we're essentially putting our names on it, that we are accountable for this piece of paper. If you want to look at it, we work for the people who initiate that document. And when they come up and ask you what's happening and you don't have an answer for them, puts you in a tough spot. Some of the root causes can actually be very simple. We had a high rejection rate on the avionics doors. We've consistently experienced a high latch load when we go to rig the doors on assembly. Over the past 6 to 8 to 12 months, we've constantly checked all the tooling, checked parts, made sure those were correct, and the blueprint, checked the blueprints to see if we had any problems. And yet we still had problems with the latch load. So last week, we essentially looked at the door again, working with the shop. We started to eliminate what variables were left, and there weren't too many left. There were only 2 seals that were riding on the door. So with shop's help, we pulled off 1 seal, and that still didn't remedy the situation. So we narrowed it down to 1 seal on the forward, on the nose barrel avionics door, and it looks like that was the root cause.
A lot of people on the floor feel that a minor problem to them can be whisked away with a phone call. And I don't blame them for having that attitude, but I hope that we can convey the message that we need to research every problem that we get until we know exactly where we're going from step 1, step 2.
Well, what you got to realize, though, is that there's 42,254 detailed parts on an F-15 Eagle. So that's a lot of parts and a lot of problems to deal with. And it's not always easy to maintain a consistency because of manpower turnover, tooling wears. We could have fabrication problems, and we get those cleaned up, and then we might experience assembly problems.